my first attempt of the introduction for this talk was actually to rant on wikis. Why? So they're an easy target. Every company has a wiki or similar document-based, and I would say that everyone has some outdated information in their wiki. So it's easily to make jokes like this. Or another one is this. Yeah, so, but the thing here is that the wiki is not the root cause. It's just a symptom, or the wiki is just a medium where this outdated information is stored, or so it's not the root cause. And so here's my new introduction. I hope you like it. So documentation is everywhere. We have, I don't know, like user documentation or system documentation and overviews like architecture diagrams and so on. We have software requirements, we have API documentation, we have ops instructions and runbooks and stuff like that. So there's many kinds of documentation out there. Yeah, and there's also certainly a place for documentation. There's also good documentation out there. But this is my statement. I would say most of the time we should ask ourselves how we can avoid writing documentation. And this is why, so now some thoughts, because that maybe are the base of why I'm thinking that we should avoid documentation. So the first is, could we just replace documents with direct communication? So, for example, DevOps anyone? Could we just, and again, DevOps, could we just adjust team structures to shorten communication paths? So just maybe just put the ops person into the development team and let them pair so they don't have to write, I don't know, tickets or whatever, which is also a kind of documentation. Can we automate it? We had this example of the style guides in the presentation from Dennis and the other guy. Sorry, I forgot his name. So just automate the documentation. Can we? And we also have to ask ourselves, what is the value of the documentation? Because do we know if anybody actually finds or reads the docs? Or if anybody understands or use the information? So this is very hard to track. So how do you track if, I don't know, someone reading the documentation really understood what you tried to explain there? And there's another problem, like this is the base of the outdated wiki jokes, like did our documentation already drift away from reality? Did it become outdated? And there's also a cost of maintaining documentation. So, and creating and maintaining documentation. So what I mean is, you could spend this time maybe more worthfully in other parts. For example, we could just use this time to deliver working software. So remember Agile Manifesto. And there are also not only costs of creating and maintaining documentation, but there's can also be cost of outdated or wrong information. So who's question, who's on call here, or where's the pager right now? No one? Where are the ops people? This is Ops Summit. So yeah, what could happen is that in the middle of the night you have to follow some instructions, and then you notice that they are outdated. And the question is that really fun? So how can we make sure that we only create documentation that is worth it? And how can we make sure that it's up to date and actually being used? And once again, we saw it several times this day. This is how I got to the real issue. I think that the real issue we have to talk about is feedback loops again. So who knows this? Quite a few people. That's great. So PDCA stands for Plan, Do, Check, Act, and is actually the mother of feedback loops from the father of modern quality control, Edward Deming. Remember this name? And here's how it works. So simply, you plan something like I want to have user documentation, whatever. Then you do it, and then you check up on the results, and you also check is the outcome the desired outcome, and then you act up on your new learnings, and then you start over again. And this is the important part. You start over again. You don't stop there. And in Agile, we have feedback loops all over the place. So do you know any feedback loops in Agile? Retrospective, correct? Daily stand-up, yeah. Also more technical. CI, correct. For example, also red-green refactor, like TDD, is also a feedback loop. You write a failing test, you implement it, it's getting green, you refactor it, and then you start over again. And there's also other feedback loops are everywhere. So this is another example. Who knows this? What is it? It's a lean startup. So build, measure, learn. And this is just another form of PDCA. So, but they start with do. So when you look around in your company, you look at something which is done, then you usually, so for me, it's usually I have the feeling often that there's not PDCA, but there's only, I don't know, P and D, or so they forget to check stuff. Or sometimes there's only D, like doing. Yeah, so yeah, this is like, this is build, measure, learn, and you could also say like, okay, I want a new piece of documentation or whatever, and so I build it, then I measure the outcome. For example, is it used? Is somebody actually using it? And then I learn from it, and then I start over again. So you can see also documentation as a product development cycle. So what I would say is like PDCA all things. In order to make sure that our documentation is used, understood, maintained, and up to date, we have to put in PDA cycle on it and adapt it regularly. And this is more like the lean startup paradigm is you could just treat every documentation effort as an experiment and then just apply a feedback loop. So I used PDCA as a verb here. Don't know if it's good English. Okay, so now let's have a look. So actually this is the this is my new intro. Did you like it? Everyone awake? Great. So there are some animated GIFs coming, so you get awake again. So now let's have a look at some patterns how we can avoid static documentation. So I would say like this is the paradigm: no document is better than no document. I adapted this from the joke, no software is better than no software, because if there is no software or no document, we don't have to maintain it and we don't have to put a PDCA loop on it. So again, simplicity, the art of maximizing the amount of work not done, is essential. This is what also the Agile Manifesto is saying, because we are talking about Agile documentation here. Another rule of how we can avoid documents is just use better ways of communication. Or if you use it, so if you're using documentation as to communicate, you could use better ways. So for example, this shows the richness of communication channels, and what you can see on the actually, I forgot that I have this one. you can see that on the top right, that face-to-face communication at the whiteboard is the richest communication channel. If you ever have the possibility to do it, then use this technique and not like chatting or throwing Word documents in emails or stuff like that. So here are some people at the whiteboard, and the cool thing is here that you can just keep it up to date when it's co-located, and when your team is co-located, you can just keep it up to date. It's always in sight and visual range. What you can also do, simply do, is change how your teams works. So if you have like if you have document passing between or whatever passing between devs and ops teams, for example, why not put them together? And there's this cool website called devopstopologies.com, and this is a cool overview of how you could reorg development and operations teams. So the next pattern I have for you is called single source information, and now we want to have a look how we can create documentation, or how we can automate the documentation creation process. And so instead of duplicating information, like what was said before, like putting stuff into PDFs or like that, it's a good practice to create views from a single source, so we can just avoid outdated duplicates. So here are some examples. So for example, we can embed architecture diagrams without without using a, I don't know, diagram editor or something like which is on your desktop. So here's one example. This tool is called Graviso. Who knows it? Dennis and another person. Great. So what you can see here is that you actually have a markup language, and in your so the source attribute shows a kind of a DSL, which is then rendered by their server to this nice graphic. And this is how it looks if you put it, for example, in GitHub in your README. And the cool thing that it's now co-located to your README, and it's not like somewhere in a wiki page or whatever, and you have to open a graphics editor to do stuff and to update it and so on. So, and the image is rendered every time when this image is requested, so it's always up to date. That does not mean that a computer is actually changing the diagram source code when you update your architecture. So this is still up to you. There are other examples for API documentation. So, for example, this is a Swagger file. It's a language to explain or to describe APIs, and it's really cool because you can also check this in or generate it from, I don't know, other IDLs you have or so interface description languages or whatever, and then you can just generate fully automated an API documentation, and it's so cool that you can also, if you have an API key, you could just edit, put the API key there, and then you could interactively also browse through the production API, for example. So it's not just static documentation. Another example is PlantUML or PlantUML. So for example, this screenshot shows the IntelliJ IDE, and it shows the PlantUML plugin. So you can see there's a doc block comment in at the top of the file, and the PlantUML plugin will just show the diagram, so you have more. The information is really very close to you, and you don't have to go somewhere else. So again, this is still manual work to keep the comments up to date, I know, but at least we don't have to open a graphics editor or whatever to update the what is it, sequence diagram or whatever it is. So the main paradigm here is views, not copies. So you have your artifacts, or you have your inputs like A, B, C, D, and so on, and then you use view generators to to create the views you need for specific documents. And there's more stuff. So this is a really there's a really cool presentation linked here. So if you want to know more about this stuff, just check out these slides. So that's very cool. So now we got a single source of truth. We have it all versioned in one same repository. It's very likely up to date, very likely. And it has low maintenance because usually this building stuff is also automated. So the next thing I have is prefer executable specifications over static documents. So who knows the term executable specification? Quite a few people, great. So what are examples, like example languages or tools? Yes. So Gherkin, yes. So actually everything which is like an automated test is an executable specification. So this is the like the overall term for it. So we use DSLs, and what you can do is, for example, acceptance test-driven development, or also called BDD, or behavior-driven development. And here's an example. This is Gherkin. Who knows Gherkin? Like this language, given, when, then. Quite a few people. So this is an example, and it just you can see the steps like given, when, and then. And this is actually, and what you as a developer or a developer has to do is implement this the so-called steps. So the agile part here is also that this is usually paired with the product people. So you don't sit down and in your chamber and as a developer, but you go to the product people and try to extract the specifications or requirements out of the brains by using this language. Yeah, and then you put it into Jenkins, and then you get this nice documentation. So Jenkins or another CI tool. And if it breaks, the documentation gets red. So in this case, it's red cucumbers because the tool is called Cucumber. So again, we have a feedback loop here. So we are the CI server. We have the build fails when the documentation is out of date. So this is actually also a feedback loop. And because usually you would stop development then and say we have to fix our pipeline, for example. And we have this collaborative requirements engineering with the product people. We have readable product requirements because you can just read through it, and it's not like a cryptical unit test or whatever, which only developers understand. So this was mostly software development focused, and I thought, okay, this is the Ops Summit, so let's make it a little bit more Ops focused. So who here is running stuff in production? Like you are not on call, but you are responsible for it? Some more people. So anyone else is doing the on call? So the cool thing here is that you can also use this acceptance test driven stuff for operations, and I have an example here. So if you want to monitor google.com, which everyone wants to do, and you want also to check if it's working, you could use the language to describe this scenario. And what you can see is that actually you check. So what you are doing here now is you check the functionality of your website. You don't check if any server is down or whatever, because who cares? This is this is what we care about. We care that our website provides service, and this is the service we check. Or another example from my colleague and friend Dennis is this one. It just shows how you can, for example, check SSL certificates with this language. And then you can put it, for example, in your Nagios or whatever. It's just a shell, not shell script, it's just an executable. So you could use, for example, Cucumber Nagios, and then you get it back into your monitoring and alerting. So, okay. Now we got no static documents anymore. We have automated feedback loops. We have self-validating documentation and monitoring. And now some more general tactics for this. What I already said, you have to also evaluate like the check phase of the PDCA cycle. So what you could do to evaluate the usage of your documents, for example, a very simple example could be like you use Google Analytics or whatever. Another cool thing I found is use janitor engines. With janitor, I mean like automated engines which clean up, for example, your wiki. So, for example, this is for Jira or Confluence, and what it does, for example, is like it annotates outdated pages. So, for example, if it wasn't edited for, I don't know, a bunch of months or whatever, and then it warns, and then it will just remove or archive the page. So the cool thing here is that people usually don't argue with computers. So if I would send my colleague an email, hey, this is outdated, can we delete it? No, 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 there's some information in it. But when the computer says, then you might not care this hard, I don't know. So at least this is my observation. And so if you really want to write technical documentation, and you have to check out this book. And there are more practices here. And so now comes the last chapter of my talk. What I now want to show you, because this is the Ops Summit, is how can we just drive Agile Ops documentation to the extreme. So now it's time to wake up. So usually we have some procedures, or maybe for a database restore or failover or whatever. So we document the steps to do, so the person on call can execute these instructions. And we hope that we never need it, but usually the day or night will come. And so I have a few questions for you. So who uses runbooks to document operational procedures, or however you call it? So who believes that they are up to date? No one anymore? So, and the question is also, how do you know they are up to date? So how could one know? Testing, correct. So like the firefighters in this image, you need to exercise and review your instructions regularly. And because there's no other way to ensure that the instructions are up to date. And there's also no other way, so at least I believe, that your ops people have confidence that the instructions work when they have to work. So let's have a look at the simple feedback loop for a runbook. You create or plan a document in your runbook, for example, for a database failover or whatever. Then you execute the instructions. Then you check if the instructions work and if it's the desired outcome, and then you update your document with your learnings. And you reschedule. So this is again the loop part. And we have a feedback loop again. So PDCA cycle check. And you would say, okay, that's great, but there's still a document, and we want to avoid static documents, because this is the goal of my talk. And what we could do, we could automate it even more. So after a few iterations, over manually exercising all the stuff. So I would recommend to do it always, to exercise it first, because then they should have become quite stable. Then you know what you're doing, and then they become a candidate for automation. So again, our feedback loop now looks like this, like you automate the instructions. So for example, so I use usually Ansible for it. You execute the run book, or which is now an Ansible playbook. You check if the outcome is desired, and then you adjust your automation and reschedule this again. So we have feedback loop, and we have no static document anymore, and no error-prone manual instructions. So this is quite good. But I said to the extreme, so we have to go further. So as an ops person, for example, you could now simply use this Ansible playbook instead of following error-prone manual instructions. But here's another problem. So imagine this is one point in time, you execute automation, for example, as a regular exercise, as I showed you. And this is another point in time. So we are confident that our runbook instructions work at these two particular points in time. So what about the time in between? How can we be confident that our instructions are still working? Because the thing is that the external conditions change all the time. So I don't know, a database upgrade or whatever. So you just can't be confident that your instructions work. So what could we do? More automation? Yes, correct. So actually what we could do, we could automate the running. So we could just use a scheduler, like for example Jenkins again, and it just schedule the run of these instructions every day. So instead of manually testing the instructions or executing the script or playbook. So we can do this as often as we want. So for example, we can just shorten the feedback cycles. And I would say this is pretty cool. And because now we have an automatic feedback loop. So the PDCA checking is done for us. We don't have to do it by ourselves. We can save time. We have no static document. We have no error-prone manual instructions. And we also have fully automated regular test of runbook instructions. And we have confidence through short execution intervals. Oh, the other talk is finished, so I should hurry up. Okay, so now I'm taking you to the last and so the next and last, currently I would say last level invented in how you could train runbook automation. And this is another level. So why not execute all these runbook instructions in production, like the database failover? Randomly and automated, like we don't know when it happens, all the time or during office times, and without a warning. So, and this is actually what I would say the ultimate runbook automation. So who knows this little guy? Ah, that's great. So this is Chaos Monkey, and I have an example how it works. So let me illustrate with an example. So we have our master database, and it's doing fine, and they are replicating and stuff. And now what we do, we unleash the monkey. So actually it unleashes, or he unleashes himself. And some random time, usually during work hours, because you want your people to be, if there's something going wrong, you want them to be there. And it will randomly shut down or terminate or whatever you want, because you define how it will behave, one of your database nodes. So it will just shut it down, kill it, terminate it, whatever. So in production. And now your entire application has to deal with it. This process has to be automated. The apps have to fail over or whatever. Whatever is just accessing the database, and also your entire infrastructure has to take care of recovering. So no manual process in production. And you would say, well, this is crazy, or some people, but the thing is that it's so cool because what you gain from it is that you get the highest form of confidence in your infrastructure, because running it all the time is confidence. So there's also no excuses anymore. There's no, but it worked in staging. There's also, you also have to make your failover procedure fast, because there's traffic on your production website, and people should rather see no 500 errors. So no one needs to be paged in the middle of the night. So your people who formerly got paged have now more time automating even more stuff and making themselves more obsolete. Sorry. And this is, for me, this is the most important point. Now, what was formerly a near disaster for your organization, like, oh my God, database failover, we have instructions, but we actually never tested this, is now a non-event. So it's now like, okay, maybe you look into the chaos monkey event log or whatever and see, okay, it was executed at noon or whatever. Then for me, so this is why I'm really feeling like mind blown. Because this is really the highest level. And if you want to learn more about this stuff, this is the website of Chaos Engineering. And these are some projects like Stackstorm. I did not find the time to try it out, but the cool thing, for example, is that the Netflix people are now adapting it, and you can see the link. So I will put the slides online later, so you can just copy and paste the links. So I will leave you with this slide. It's actually, we saw the journey from static wiki page to fully automated Chaos Monkey in production, and we also saw a journey. So I would say everyone starts with a wiki page, so don't be afraid. And this was all I got. Thank you.